Hello, one and all. Welcome to Gliding Through Blindness. Today we're talking all about AI. One of my favorite topics. It's hard for me to keep up. I've had to add more to my notes almost every day because things are just happening at a breakneck pace. Um, and so be sure to look at my recent video all about the what I do to keep my health regulated. And it's pretty simple. But I'm not going to give anything away here, but just be sure to check it out. And also the convos with Kim that I did recently, all about the arbitrary lines that society draws, um, and when and if they should be changed and how, etc., etc. Quite fascinating. Um, and so with that, um, I just have to remember here way back, like several weeks ago, when I first started taking these notes, and human reinforcement, or reinforcement learning, is one of the ways that people trained these large language models and now large reasoning models, where you can actually see them thinking, quote unquote. Um, And of course, reinforcement learning, you've probably learned about it in psychology classes or whatever, but it's basically where you reward the behavior you want, and sometimes negative reinforcement, you take away rewards. So, like in this case, with when the model does something you don't like, you might lower its score or whatever. So it learns. That's what you do in training. It learns. And gets better by this reinforcement. And so you're basically teaching it how to think. And now, though, these models are able to figure things out um, without the training or without nearly as much training. You just, instead of continuously giving it more and more and more data, it's able to figure out things with less because the data you are giving it is better because it builds on before, which we've talked about in my other AI videos. So be sure to check out that playlist if you, because I'm not going to repeat myself, or at least repeat as little as possible. So you can have the whole concept, but also they're using this chain of thought reasoning, um, where it just keeps following the most likely path every step along the process. And like these trees, I forget the word now, but these, it goes to the most likely branch, or in other words, and this can lead to emergent behaviors that we didn't expect, such as when it won the AlphaGo game several years ago, which is kind of like a chess game, and it thought of a move that humans had never considered, so it was able to outplay um, any human at that point and keep improving because it can just play millions of games or however many until it learns, hey, I bet this would work, even though it was never taught that and no human had ever really done that before. And it wasn't until after it had made the move that people realized, wow, yeah, like why didn't we think of that, I guess. But and so, like this recent deep seek phenomenon that happened that I talked about last time, um Nvidia's stock went way down after that because people thought that it was way overpriced now because we wouldn't need nearly as many chips from Nvidia anymore. But um, no, it just means that we can do more with the data we have. But I don't think you'll ever be able to make enough or too many. There will never be an excess. They'll be gobbled up, these chips, as soon as they are made, because people just will keep thinking of more and more ways to use them, which is why I'm also not that worried about the labor the crisis that will happen that some people worry about when we really enter this age of robots. I mean, I think there definitely will be a time of turmoil and a time of adjustment, but I think humans are just always going to be able to think of other ways to other jobs that we never would have thought of until we're put in the position. And we'll just keep innovating. And I think that's just kind of human nature to use the tools that we have available to us. And if some jobs are the current jobs as we think of it, or labor is done by or is automated, we'll just be think of new ways that it's hard to predict now what those might be. But I don't want to go too far astray from the main point here. But the Jevons paradox is one thing that was mentioned. Like an everyday example is the cheaper gas gets, for example, the more we use, the more gas we use, because um, people travel more and farther because now that they don't have to pay as much, they it's still they have like in their budget or whatever the same amount of money, so they still spend it what they would have normally spent, but it goes farther because the gas prices went down. Um, and so OpenAI released O3 Mini and O3 High just recently, since my last video, which was last month, where you can just basically tell it what you want and it creates it. Like video games or whatever, better than any other model. You can just, and it just does it on the fly. Like you can just say, do this while it's um, like generating this, whatever you want. Um, and so, like, pretty soon, prompt engineers won't even be needed anymore. Um, or at least not in the capacity not in the job that they're doing right now, because you won't have to know just the right way to speak to get what you want out of these models like you kind of do now. Like at first you needed to know the coding. Now you don't really need to know that anymore, which I'll get into in a minute, because these computers are soon going to be able to code better than any human, but they still have to know exactly what to say in English to the computers to get the best output, which we kind of have do too in our everyday lives. Like my Meta glasses, I get a lot more out of them if I prompt it in the right way. Um, and so you'll but soon you won't even need to know. They will be smart enough that it will just be able to figure out what you're trying to get at. So you won't have to be nearly as precise. You can just kind of say something went wrong here. Can you figure it out and fix it? And now deep research has been released as well, and that's a model that you can just give it a task and it will go on the web and do all this research from all the various websites and stuff out there, and it will write a research paper for you within just a few hours. Where if this was a project you had to do, you might be working on it all semester, or it would at least take you days to compile everything and write the paper just how you want. And you can just tweak it however you want. In fact, before it will even go and do it, it will ask you a bunch of questions, like narrowing it down, like the focus that you actually want, so it can do the best job for you. Or you can just kind of let it go and say, like, use your best judgment or whatever, and then it will do that too. But it's just amazing how um, it can just do that no matter how complex the topic or whatever. And you can tell it the format you want, or you can say, like, put a lot of tables and graphs in this research paper, and it will just do that. Um, and and then it of course includes all the links in the paper so that you can go and check the primary sources and verify that what it's telling you is correct. Um, and um, like scientists are using this things tools like this now to figure out things about like how the universe came into existence, or things about health. Like this one guy told a story about how his wife had breast cancer, and they asked this deep research to write a paper on the different, because they were just kind of overwhelmed by what the doctors were telling them. It was just too much information for them to take in. But this paper or model just wrote the paper for them, this deep research, and they were able to like easily see like how the different possible treatments differed from one another, and what the pros and cons were of each one, and the cost, and on and on and on. So it just really gave them peace of mind. So I mean, these models aren't just fun and kind of, oh cool, like they actually have practical real applications in the real world, and it will just become more and more that way as we figure out how to use these things. And like you can ask it like which proteins might be needed or to solve things, or like because you can these computers can test millions of combinations in a fraction of the time that it would take a person to do it. Like I was talking earlier with the AlphaGo game, because they're not limited, they don't ever get tired, or they can work 24/7 on one particular thing until they master it or whatever. And now these computer models are even starting to come up with their own language, um, when English isn't adequate to express the things they're doing. Like they can just kind of talk to each other. Um, and in their reasoning process, because and you guys can relate to that, like sometimes another language, if especially the bilingual people out there, they realize that there are some words that can't really be totally expressed in another language, because the other language just doesn't have a word for that particular thing. So then they have to like come up with different ways to describe it or whatever, and that's kind of what these models are doing. um, and So that's just kind of wild to think about. So the next model that in a few months' time that OpenAI is predicting, I don't know if they're going to end up calling it, if it's going to be O3 something or O4 or whatever. Seems to be their current naming. It doesn't quite all make sense to me, the names they come up with for these things sometimes. But it will be uh, within the 75, like better, only 75 people in the world basically will be better than it is at coding. And Sam Altman said that internally they already have a model that they're not going to release yet, but that one is better, or only 50 people in the world are better than that one. So that's why he's confidently predicting that by the end of the year there will be a model that codes better than any human. So that will just really be an intelligence explosion when we get to that point. And that's when we'll really start to be able to discover new new knowledge and new science that was previously unknown. Like right now, we're just at the phase where we can research what is already out there and synthesize it and stuff, which is pretty phenomenal in itself. But soon the AI will be able to discover new things, which is so exciting to think about. And recently, our Vice President, J.D. Vance, spoke to Europe about how important it is that they get on this bandwagon with us and join with us, because they're just falling behind because they have such strict regulations over there. They're prioritizing safety and privacy and stuff, which it is very important to prioritize all those things. But sometimes you just have to decide, well, but what needs to be the biggest priority right now? And like, it just is sad how rigid they are. Like, on my glasses group, that the Facebook group I created several months ago, the people on Europe or in Europe that are on there don't have access to the same things at the same time as we do, and it's very upsetting for them because they see how cool these features are and they're saying like, when are we going to get this, and why doesn't Meta think of us too? We're customers too, we bought these glasses. And they don't realize that it's not the fault of Meta or the fault of the United States. We would gladly let them have access to all this if only we could, but because of the regulations in their country, um, it they don't have access. So that, yeah, like just that's just on a very small scale, but it's it um so yeah, I guess that's that tangent. And I also recently just listened to a video about the fact that AI is becoming less susceptible to human manipulation, and some people might be kind of scared by that. But the video I listened to from David Shapiro, he's getting kind of back into the AI groove now for a while. But he thinks it's a good thing because they're tending toward more universal values. Um, and not so they won't be subject to the whim of the individual corporations or individual countries or whatever that might be training them, um, because as they become more intelligent, they're becoming more resistant to corruption from a single entity potentially. Like they'll just so they're the way he put it is they're optimizing for coherence and not for a particular like set of values that could conflict with another set of values. So overall it's a good thing. um and Also I heard a an interesting remark. I can't remember who said this, but um communication is basically just human prompting. So when we communicate with each other, I mean, you can put a negative spin on it if you want and say like, what are your motives, or what are you trying to manipulate me or whatever. But actually what we're trying to do when we communicate with one another is we're trying to get people to see our point of view or understand where we're coming from, or getting them to like do a certain thing. But the better communicators are basically just can be that you can draw a parallel to like the prompt engineers too, that the better you are, um it's you get more out of whatever whomever you're talking to. um and so it's how to get the best result and the most cooperation, basically, that will end up benefiting everybody. The better we are at these things. Um, and I also just recently watched a video. Sorry, this isn't like the best organized because I just, like I said, have to keep adding on as I hear more and more things. But this model now that this guy was talking about, Matrogen, I think it's called, but it will make any material, like any chemical material or any other material, um, with the specific properties that you want or that you ask for. So like it uses the known elements in the periodic table, and so like you can say I want something with this magnetic property or something that does this certain thing or whatever, or this density or just whatever. And the more compute you give it and the longer you let it think about that, it will generate more materials or more possibilities for you to use. So like just think of the what that will mean in the scientific field, to just have these tools that can so quickly like do hypothetical testing and stuff without you needing to actually physically go and do it in the lab, because it already will be able to figure out what would happen and just save so much time. um and now YouTube has come up with a little neat feature. Hopefully it's a good thing, for their premium subscribers. It's called Ask. and it basically gives you a summary um, of the video that you're watching, complete with timestamps. So, like, if you don't have time to watch the whole video, you can just read this summary and play the parts you want or whatever. And the guy that was talking about it, though, was kind of worried about, well, now people aren't actually going to watch anymore. They're just going to look at the summary. But I don't really think that's the case, because I mean, I much prefer watching these interesting videos and getting the commentary like expressed verbally instead of reading a bunch of articles and stuff. So I think in a way it will be helpful, because you'll be able to, like, or if there was a video that you watched recently, you can just ask this tool, like, find the video in my recently watched or whatever that talked about this, or find that particular segment, because I'm sure I will, if I was a premium subscriber, but eventually it'll be rolled out to everybody, I would probably share more of those actual um, video segments with you guys if I could find them that easily, instead of having to try to figure out, now who was I listening to that said that, and now try to find it in within the video and stuff. And that just seems like more trouble than it's worth, especially when there's so much that I want to cover in these videos. But that will make it much easier. So, like I said, there's always going to be a give and take. There's always going to be negative aspects and positive, but we just have to choose to use them positively. And I mean, I'm sure there will be negatives too, but I think the positive will far outshadow that if we're careful and cautious and think ahead, and try to address the problems that do come up, and not just stick our head in the sand and ignore them, but yet be realistic too, and not just be doom and gloom, and try to think of all sides equally. And so, like, you can just see how transformational all this stuff is, looking back as how far we've come just within the last year or two. Um, and and now they're making models that think internally without using any tokens. So just think how much that will save on compute. Um, and like, sometimes though, we want to see, it's kind of cool to see how it is thinking and reasoning. Um, but some things are, just like I was saying earlier, really hard for them to describe in English. So that just kind of slows down the whole process. But um and that will even become more true as things they get more complex and smarter than we are. But we can also, in the meantime, we can use a combination of this latent space thinking and the tokens thinking. So maybe it will, like, think for a while at first and not generate any output. And the example this guy gave was, like, when you're doing a math problem, you might think about it first, like in your head, okay, what should I do first? And then you'll write it something down, the first step, and then you'll think about it more. Then you'll look back at what you wrote. So it can use a combination of these things too. Um, and so, yeah, that's just a few of the highlights that I wrote down. It was really hard for me to figure out what's the most important things that I should share in this video. So if you like this, be sure to hit the like button or leave comments or whatever, so that I'll do these more often if it seems like you guys are getting some value from this. And we're only at the beginning, because there's a whole other thing we could do about robotics and the autonomous driving and all that, which will probably be what my next video is about, actually, about the cyber cab that's right around the corner, and why I think that's going to be so cool. So anyway, for now, though, I just thank you for watching, and I'll see you next time. Bye for now.